Here is a sample problem on projectile motion. A boy throws a stone horizontally from a cliff with a speed of 12 meters per second. It takes 4 seconds to reach the bottom of the cliff. So here is the illustration. We have a boy throwing an object with a horizontal speed of 12 meters per second. And then it takes 4 seconds for the ball to reach the ground. Now, first question, we need to solve for how high is the cliff. So in the illustration, we need to solve for this height here. Now, let's go back to the problem. It says there that the boy throws a stone horizontally. This is a very important term when we talk about projectile motion, because when a ball is thrown horizontally, or when a projectile is thrown horizontally, it means to say that the initial vertical velocity is equal to 0. So the speed that we have here, which is the 12 meters per second, is in fact the horizontal velocity of the projectile. So that is 12 meters per second. Remember that a projectile can have two velocities. We have vertical velocity, or Vy, and horizontal velocity, or Vx. We are also given these formulas that we have here. Now, these three formulas are all related to the vertical component of the projectile's motion. The only equation that we can use for the horizontal component of the projectile's motion is Vx is equal to delta x over time, where delta x here is the horizontal displacement, or it is also known as range. So once again, these equations here are all related to the vertical. So we have vertical velocities, and this x right here is actually vertical displacement, and it's also similar to the s here. This is also vertical displacement. Alright, so let us now try to solve the problem. What are the given values in our problem? So we have the initial horizontal velocity that is equal to 0, because once again, the projectile is launched horizontally. We're also given the vertical, or rather the horizontal velocity of the projectile, and that is 12 meters per second. And we're given the time it takes for the projectile to reach the ground, and that is 4 seconds. The first question, how high is the cliff? We need to solve for h. Now, from the formula, h is actually related to the following symbols. So we have delta x and the s right here. So as a matter of fact, we are going to use the equation that has the quantity of height on it. So firstly, the first equation doesn't have anything to do with height, so we don't use that. And if we look at the third equation as well, it says a vertical final velocity, and we do not have that information, so therefore we cannot use it. And that means the equation that is most appropriate to use to solve this problem is the second one. So let's write that down. We have delta x is equal to VIT minus 1/2 GT squared. Once again, I repeat that this h here that we are trying to solve for is actually related to the symbols delta x and s. Alright, so let us substitute our values now. We have our VI. Now, what is this VI? The VI here is actually the initial vertical velocity, because once again, this equation that we have here is the equation related to the projectile's vertical component of its motion. So, of course, we are going to use the vertical velocity, not the horizontal velocity. We have VI is 0 multiplied by time, which is 4 seconds, minus 1/2. G is 9.8 times 4 squared. Now, sometimes you may use positive 9.8, negative 9.8, but you will have a plus sign here. But since we already have the negative here, then we're going to use 9.8 to substitute with the value of G. So now you just have to put these values in your calculator and you'll have that delta x is equal to negative 78.4 meters. But then, why is it negative? So it's negative because the object is thrown at this location and then it goes down and reaches a point below the point where it was released. So it is released at this point here and lands at a point below it was released, and that is why the delta x is negative. But the question is, how high is the cliff? We need to solve for the height. So this tells us then that the height is equal to positive 78.4 meters. Height cannot be negative. And this is the answer to the first question. Now we move on to the second question. How far from the base of the cliff does the stone land? So if we're going to look at the illustration, this is the base of the cliff and the stone is going to land at this location. So in fact, we actually need to solve for this quantity right here, delta x. This is the horizontal displacement. Since that is the horizontal displacement, so we're going to look into the equation that is related to the projectile's horizontal component of its motion, and this is the only equation that is related to its horizontal component. So let's write that down. We have our Vx is equal to delta x over time, and this Vx right here once again is given to be 12 meters per second. So this is the velocity by which the object was thrown horizontally. So that is our horizontal velocity, Vx. Let's write that. Let's substitute our values. So 12 meters per second is equal to delta x, which is what we need to solve for, divided by the time it takes for the projectile to land, which is 4 seconds. Put these values in your calculator. You will have that your delta x is equal to 48 meters. So therefore, it will land 48 meters from the base of the cliff. So this distance right here is 48 meters. So once again, it is very important that if we are dealing with projectile motion and if the object is thrown horizontally, that means to say that the initial vertical velocity of the projectile is 0 and that the velocity that is going to be given to you is actually your horizontal velocity. It is also very important to note that the equations that you see here are equations related to the vertical component of the projectile's motion, and the only equation that pertains to the horizontal component of the projectile's motion is Vx is equal to delta x over t, where Vx is the horizontal velocity and delta x here is the horizontal displacement. On the other hand, the delta x here is the vertical displacement.